This is All India Radio. Radioscope, the National Science Magazine program.
Good evening and welcome to the latest edition of National Science Magazine, Radioscope. Dear listeners, science and technology hold the key to the progress and development of any nation. While technology plays a fundamental role in wealth creation, improvement and enhancing quality of life of the country's citizens, breakthrough discoveries in the field of science facilitate a disease-free life and fulfills the promise of providing healthier options for improving people's lifestyle. To keep you updated on the latest developments in the field of science and technology, we bring to you the March edition of Radioscope. In the next 30 minutes of tonight's edition, we will bring to you information about fossils and dinosaurs, take you to the world of cosmos, discuss about great scientists born this month and much more. So without further delay, let's begin this wonderful journey with the news highlights from the world of science and technology. Forget screwdrivers or drills. A stick and a straw make for a great cockatoo toolkit. Yes, you heard it right. The distinction of being adept at using a toolkit does not belong to only humans. But our avian friends, cockatoos too, have shown their remarkable skills in accessing their favorite snack with the help of their woody tools. Among non-humans, cockatoos are second after chimpanzees, who have the knowledge to use tools to fix problems in their daily lives. The James Webb Telescope has spotted the earliest known galaxy to abruptly stop forming stars. According to researchers, the galaxy called GS 9209 quenched its star formation more than 12.5 billion years ago. That's only a little more than a billion years after the Big Bang. Its existence reveals new details about how galaxies live and die across cosmic time. Scientists have found the first known microbes that can eat only viruses. According to a research, tiny pond-dwelling Halteria ciliates are virovores, able to survive on a virus-only diet. The single-celled creatures are the first known to thrive when viruses alone are on the menu. A study has shown that deep-sea mining could disrupt whales' ability to communicate. According to scientists, noise produced by mining seabed for nickel, cobalt and other metals for green energy transition is the reason behind disruption of the ability of whales to navigate ocean's depth and communicate with each other. From the world of news, it's time to go on an exploration hunt to find some indelible prints etched in the history and get the memories of the Jurassic Park alive. Yes, you got it right. It's time to talk about fossils and dinosaurs. Recently, a team of researchers from the Geological Survey of India had discovered bone fragments of the Sauropod dinosaur dating back to 100 million years in the West Khasi Hills district of Meghalaya. With this discovery, Meghalaya becomes the fifth state after Maharashtra, Gujarat, Madhya Pradesh and Tamil Nadu to have sauropod fossils. Bashisha Iangrai, senior geologist at the GSI division of Shillong, who was also member of the dinosaur discovery team, tells us about her recent sauropod findings. Talking to her is Dr. Bonnie Nichols.
At the very outset, ma'am, you have played an important role as a member of the dinosaur team. So could you take us on a brief journey leading to the discovery of the 100 million year old fossil of Sauropod dinosaur and its significance?
So, based on the discovery of the dinosaur bone fossils by geoscientists of the Geological Survey of India, the research work was taken up in 2019 to study the Upper Cretaceous sediments of the Mahadek Formation. This dinosaur was found in the Mahadek Formation of the Khasi group of rocks, which is approximately 100.5 to 66 million years old in age and is mainly composed of very thick sequence of sandstone. Since earlier very small fragmentary fossils were recorded, it was highly speculative that those were considered to be dinosaurs. However, this time with enthusiasm and a lot of hard work, bigger size bones were recovered by our team comprising of Dr. Debahati Mukherjee, director, and Dr. Linashri Dalla Behera, superintending geologist. We headed to southwest Khasi Hills of Meghalaya to explore the areas of Dirang, Ranikor, Maufuli and Nongna. Initially, it was quite difficult to locate or even identify the bones, which are very poorly preserved and fragmentary in nature. But fortunately for us, we recovered many broken bones with little better preserved ones, which make it possible for identification. Then it was concluded that they might probably be parts of limb bones and a caudal vertebrae of a sauropod of Titanosauriform clade. So they are mainly exposed in small mounds deep inside the jungle away from the mainland. We found a limb bone which is almost 55 centimeter long, but it was a partially preserved one. It is comparable with an average humerus length of Titanosaurid. This humerus also shares similar diagnostic features with the humeri of titanosaurs recorded from late Cretaceous Lametta Formation of Jabalpur in Madhya Pradesh and then Kheda district in Gujarat. And they are comparable with the species, the Jainosaurus septentrionalis of Madhya Pradesh and Antarctosaurus septentrionalis of Gujarat. So based on all these morphological characters, we have identified the bone. Then also we have done the paleohistological studies. That is, we study the microstructure of the bones under the microscope. We saw a typical sauropod growth pattern has also been identified. Based on the presence of intense development of Havesian system, there was a complete and secondary remodeling of the bone tissue, which is typical of a long bone histology and growth pattern of sauropods. It is thus very thrilling that the dinosaur, which were the most diverse and abundant large-bodied terrestrial herbivores in the southern hemisphere landmasses during the late Cretaceous period, was also found here in Meghalaya.
So Meghalaya, well known for its serene and mesmerizing beauty, represents an important part of the Indo-Burma biodiversity hotspot, which is also famous for its unique fossils. We would like to hear more from you, ma'am, on the wealth of fossils in our state.
So the state of Meghalaya, as you all know, is a land of undulating hills, plateaus and plains with luxuriant greenery and a variety of exotic flora and fauna. It is rich in natural resources, beautiful forests, clouds and waterfalls, and it is also a treasure trove of fossils. Mm-hmm. Fossils form the basic time markers in sedimentary rocks. So in Meghalaya, these sedimentary rocks are present in the entire southern part of Meghalaya bordering Bangladesh, which is known as the Meghalaya Shelf sediments, comprising of the Khasi, the Garo and the Jaintia group of rocks. Mm-hmm. Of Upper Cretaceous to Miocene. So this is approximately, again, 100.5 million years to about 10 million years old. A huge variety of fossils ranging from micro to mega remains belonging to invertebrates, vertebrates, trace fossils and plants have been recorded here. The vertebrates like the dinosaur, shark teeth, and invertebrates like the mollusks, the echinoids, foraminifers, arthropods, ostracods, dinoflagellates, coralline algae, and plant fossils like petrified wood, spores and pollen, all these are recorded here. So like the ichnofossils, these are also trace fossils. We call them burrows. For example, the scolitas, thalassinoids and all, they are all found here. So in Khasi and Jaintia hills, as mentioned earlier, we get dinosaur bones, shark teeth, and most commonly, I'll say in layman terms, the oysters, the clams, mussels, snails, slugs, limpets, also, the starfish, the sea cucumber, sea urchin, octopus, squids, cuttlefish, shrimps, and also not forgetting the unicellular organism protozoa and the algae have been recorded here. In Garo Hills, the mollusks, crabs, and mainly spores and pollens, and a variety of mollusks, shark teeth, crabs, and plant fossils were recorded in South and Southwest Garo Hills district of our state. So indeed, Meghalaya is a storehouse of fossil, and everybody needs to understand and appreciate the fact that these are our natural heritage. If fossils are destroyed, with them a particular part of Meghalaya's geological history will forever perish.
Well, our state is blessed with pristine natural resources, rich biodiversity, and it's amazing to hear from you regarding the richness in the unique fossils which are present in our state. And perhaps many more, like you said, you'll set out another expedition that needs to be explored. Recently, geologists have decided to classify the past 4,200 years as the Meghalayan Age, being the most recent unit of the geologic timescale in the 4.6 billion year history of the Earth. Ma'am, could you enlighten us on why this epoch has been classified as the Meghalayan Age?
The age of the Earth is approximately 4.54 billion years old. The calendar of events in the Earth's history has been described by Earth scientists as the geological timescale. It is divided into eons, eras, period, epochs, and ages. So in this long history of the Earth, the Holocene is the most recent stratigraphic unit within the geological record, and it began about 11,700 years ago. And the Meghalayan Age is the newest entrant in the geological history of the Earth as part of the Holocene epoch. So in this Holocene epoch, we have the Greenlandian Age, the Nordgripian, and the Meghalayan Age, which initiated at 4,200 years ago and continue to the present. Why Meghalayan Age? The lower boundary of the Meghalayan stage is defined at a specific level in a stalagmite of Maumlo cave near Cherrapunji in Meghalaya. Okay, this stalagmite is now tagged as a global boundary stratotype section and points, the first formally rectified marker of a geological time period change in India, and this stalagmite of Maumlo cave in Meghalaya is now defined as an international geostandard. What is special about the Maumlo cave stalagmite was that the event under examination was represented in the mid and low latitudes, and it has preserved a very high resolution record. This Indian site was the best record after considering potential sites all around the world. So the Meghalayan Age is a period which began at 4,200 years ago, which experienced an abrupt mega drought and cooling around the globe, which has been established by uranium-thorium dating. The record of the climate over the last few thousand years was ascertained by various workers. Sinha in 2011, Berkelhammer, and others in 2012, Tiwari, 2013, with evidences of historical and instrumental records of the Indian summer monsoon variability. So one of these workers is Professor Ashish Sinha of the Department of Earth Sciences at California State University. He took the sample of the stalagmite from Maumlo Cave back to his lab, and through uranium-thorium dating, identified that around 4,200 years to 4,300 years ago, there was a significant weakening of the monsoon, which was marked by a mega drought, which then had a significant effect on the amount of precipitation, human settlements, and their food security that affected a number of civilizations worldwide. The stalagmite sample from Meghalaya provided a very clear and distinct chemical signature of a 200-year mega drought beginning from 4,200 years ago, which devastated many civilizations like the Greek, the Egyptian, the Syrian, the Mesopotamian Indus Valley. So this resulted in a new geoclimate age named as the Meghalayan Age by the International Commission on Stratigraphy.
Thank you, ma'am, for taking us through the history of the Meghalayan Age, and we are all privileged to be in the Meghalayan Age, isn't it?
Yeah.
So more importantly, let us remember that all fossils are irreplaceable. We need to conserve and preserve fossils.
From our discovery of dinosaurs, let's travel into the space and unravel the mysteries of the cosmic dawn. Scientists Dr. Uday Shankar and Dr. Saurabh Singh from the Raman Research Institute, Bengaluru, have found a clue to the origin of the cosmic dawn. Let's listen to what they have to say about their recent findings.
Dear listeners, we are happy to share with you the groundbreaking result from the CMB Distortion Laboratory at the Raman Research Institute, which was published in the prestigious journal Nature Astronomy. First stars lit up the universe when it was only 1/6 of its current age. For reference, astronomers estimate the age of the universe to be 14 billion years. This epoch in the evolution of the universe is referred to as cosmic dawn. Presently, no telescope has been able to detect faint signals coming from the cosmic dawn era, and this has left a gap in the understanding of the history of our universe. Our lab at the Raman Institute has pioneered the development of state-of-the-art radio telescopes to detect faint cosmological signals. Detecting a faint signal from such an early period of the universe is very difficult. Recently, that's about in February 2018, astronomers from MIT and Arizona State University had claimed the discovery of a radio wave signaling from the birth of the very first stars in the universe. They used a telescope called EDGES in Western Australia, located in Murchison Radio Astronomy Observatory. It is one of the quietest locations on the planet to do such an experiment. Our publication in Nature has conclusively refuted the findings of astronomers from MIT and Arizona State University. They modeled the exceptionally bright radiation from our galaxy and were able to recover a possible profile which was claimed as the signal coming from the cosmic dawn. This discovery had created excitement in astronomy community and even beyond. But the strength of the reported signal from cosmic dawn was indeed bizarre when compared to theoretical predictions. The unusual signal, therefore, led to speculation about how the universe may be different from what we understand today by the standard models that we have. However, appreciating that in such difficult measurements, errors in instrument themselves might result in spurious detections, cross-verification of such a claim had become an urgent priority. The world awaited confirmation from independent researchers. Saurabh, will you now tell us in detail how our experiment was conceived and was able to refute the findings of astronomers from Arizona State University and MIT?
The Saras 3 radio telescope, invented and built by astronomers at the Raman Research Institute, has conclusively refuted the claim of discovery of cosmic dawn signal with 95% confidence. The Saras 3 radio telescope is the first telescope worldwide to reach the required sensitivity to cross-verify the claim of EDGES experiment. We find that their detection was a plausible instrumental contamination and not a signal from the depths of space and time. Our results implies that the theories explaining EDGES signal have no observational support. Our findings restore confidence in the current understanding of the evolving universe, re-establishing the prevailing cosmological model of the cosmos. Our efforts to detect these faint signals began a decade back when we designed the first Saras dipole antenna, which stands for Shaped Antenna Measurement of the Background Radio Spectrum. We then refined the design of the telescope to have spherical and disc-cone shapes. Our radio telescopes needed to be deployed in locations with minimal man-made interference. Therefore, we carried out site surveys across India, ranging from our field station in Gauribidnor, organic farms in Timbuktu Collective near Anandpur, near pristine lakes of Ooty, to 4,500-meter high plateaus of Ladakh. Based on our search for man-made interference-free sites, we carried out astronomical observations at Timbuktu Collective. This deployment with a spherical antenna led us to rejecting 10% of the theoretically predicted models of the cosmic dawn. We were the first experiment in the world to constrain physical properties of the very first stars and galaxies using the 21 centimeter signal. It was around the same time that Edge's experiment announced their findings of the cosmic dawn signature. We subsequently shifted our focus to cross-verify their bold claim. Our first attempts by deploying the telescope near Pangong Lake and Indian Astronomical Observatory at 13,000 feet did not lead to the required sensitivity. We attributed this to the confusing radio waves that were emitted from the stratified ground. To solve this problem, we took an innovative approach to antenna design. The antenna, an aluminium cone placed on a styrofoam raft, was floated in middle of a lake to ensure there would be no reflections for more than 100 meters in any horizontal direction. Moreover, the slow speed of light in water reduced the effect of reflections from the lake bottom, and the uniform density of the water made the environment much easier to model. Saras 3 is the first telescope worldwide to observe on water. In an expedition in early 2020, the radio telescope was deployed on lakes in Karnataka, on Dandiganahalli Lake near Chikbalapur and Sharavati backwaters near Shimoga. Analysis from this deployment led us to conclusively rejecting the findings of ASU MIT astronomers. However, the deployment had to be called off abruptly due to the lockdown. The short observation period has prevented us from reaching to deeper sensitivities to uncover the true 21 centimeter signal. Therefore, we are planning more observations on remote lakes in India, especially in the wilderness of Ladakh. Such expeditions will allow us to detect the 21 centimeter signal from the cosmic dawn and unravel this last remaining gap in the history of our universe.
Artificial intelligence is a fast developing field of technology. We have been witnessing its applications in manufacturing, defense, engineering, medicine, agriculture, and scores of other fields. But does it not sound strange that it can be utilized in composition of music and other art forms? Not really, says Professor Shayan Sriniwas Garani of the Department of Electronics, Systems Engineering, Indian Institute of Science, Bengaluru. Professor Garani is here to demonstrate the same.
So I'd like to describe how, using Markov chains, we can algorithmically synthesize music. And this is one of the interesting facets where statistical learning and music finds applications together. So what we have done is developed a theoretical framework for representation and automated synthesis of South Indian music based on symbolic dynamics. So this is done by translating the lexicographic rules of a raga to constraints on a Markov chain whose state space is a layered graph. So we analyze the statistical properties of such Markov chains from the point of information theory and learn the statistics and parameters of the model driven by data. For this, we collated a lot of musical compositions from various composers set to that particular raga. We then braided all the notes together, and then we learned the parameters of the underlying Markov chain, and once the engine is ready, then it can beautifully synthesize music. We were also able to generate gamakas artificially, and what musicians think that music is infinite, and in this notion we were able to say what exactly is the entropy of music. That is, music conveys information through silence and sounds. This is a very interesting side of research. We are also pursuing deep neural network architectures, such as using recurrent neural networks and LSTMs, along with generative transformers to synthesize other musical genre forms, such as Western jazz, etc. This has very interesting applications and opens up a new field of how arts can meet science with a unifying umbrella of mathematics, which explains the underlying science behind the musical art. For example, in the raga Shankara Bharana that we know, right? Sari gama pada ni sa sa ni da pa ma ga re sa. This is how the Arohanam and Avarohanam will go. Tadari na 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 na. So this has a lot of embellishments and gamakas. Of course, it is not easy at a first shot to create all these gamakas together, but we have made an attempt how we can synthesize such notes through mathematical constraints and weave all these notes together in the form of braided notes to form this raga. And here is a snippet of this raga, which is composed by the musician. In this case, the musician is the computer program.
Wow, that was quite a scientific somersault. Now it's time to remember the great scientists and inventors born this month. Tring tring. This one sound is something all of us are familiar with. Do you know who invented the device which produces this sound? Yes, it's none other than Alexander Graham Bell, born on the 3rd of March 1847 in Edinburgh, Scotland. Bell is credited not only with the invention of telephone, but also telegraph, photophone, aerial vehicles and hydroplanes. The most famous scientist of all time, Albert Einstein, was born on 14th March 1879 in Germany. Einstein is famous for his theory of relativity, which revolutionized our understanding of space, time, gravity and the universe. Besides physics, Einstein also had passion for music and philosophy.
Start, 2, 1, booster ignition, and liftoff of the Space Shuttle.
Kalpana Chawla, the first woman of Indian origin to go to space, was born on 17th of March 1962 in Karnal district of Haryana. Her legacy inspires all aspiring astronauts, especially women, to dream and fly high with ambition. It's time now to take note of the important medical and scientific awareness days observed this month. World Wildlife Day will be observed on the 3rd of March, with this year's theme being Partnership for Wildlife Conservation. World Glaucoma Week will be observed from March 7 to 13, with a mission to promote and care for the eyesight. March 9 will be observed as World Kidney Day, with this year's theme being Kidney Health for All, preparing for the unexpected, supporting the vulnerable. Friends, it's now time to wrap up our March edition of the Radioscope. Hope you enjoyed and gained a better understanding about the world we are presently living in. For more such fascinating facts and scientific developments, do tune in to our next edition of the program at the same time, same channel on 14th April 2023. Till then, find yourself a reason to stay in quest, and we promise to satiate your relentless curious mind every time. You were listening to the March edition of the Radioscope. The program was scripted and produced by Preeti Prabhakar Khate, and the narration was rendered by Ashish Abraham. This was the presentation of the Central English Features Unit of All India Radio, New Delhi.